So far, we've been mostly on the blue side of things this ATT&CKcon. CrowdStrike's Sajal Thomas and Vishnu Raju are here to bring you some red, some purple, and some adversary emulation. Please welcome them to the ATT&CKcon stage.
This is an adversary that has been operating for a very, very long time. And one of the most interesting malware toolkits that they have is extremely stealthy and extremely sophisticated, and that's the focus of our talk today. So yeah, attack is the best defense. Roman origins for this phrase, a little bit of wordplay, of course, because of attack, but yeah, offense is the best defense. We've heard it a lot in sports. Apparently, it was first originated in the military. It has roots in the Roman Empire, and no, I don't think about the Roman Empire, but there are some traces in Sun Tzu as well, but yeah, we don't really know where it came from. But offense does really help defense, and quick introductions from us. Sajal Thomas, I work at CrowdStrike. I have spent my entire career in offensive security, and as a result of which, I'm somewhat of a connoisseur of the finest adversary tradecraft, which is just a fancier way of saying that I'm a bit of a snob, and I judge adversaries based on their tradecraft and trash them when they do things that are not OPSEC safe, whatnot. But yeah, that's me.
Hi, I'm Vishnu Raju. I work in the same awesome adversary emulation team at CrowdStrike. So I worked on both parts of the sides of security, the red and the blue. So I was a threat hunter and I was also a red team operator. I love my job. I love security, every parts of security. So I wear many hats, but red is my favorite.
All right, so let's dive right into it. What is adversary emulation? There's no industry-specific definition, but the consensus is that it's an intelligence-led approach. So you're trying to emulate a real-world adversary, do exactly what they did, and it's very specific because of that. There's no hypothetical scenario like red teaming or adversary simulation where you say that go get domain admin or go steal the CEO's emails. No, adversary emulation is you do exactly what the adversary did and follow the same path of the tradecraft and the same objectives. And naturally, that means that you're validating your defenses against that specific adversary and that specific tradecraft. So who are we emulating? Well, an adversary that needs no introduction in this room, at least. Venomous Bear, popularly known as Turla in the industry. CrowdStrike tracks them as Venomous Bear and assesses them with high confidence to the Federal Security Service of the Russian Federation. They've been operating for a long, long time, nearly 2 decades, and most of their MO or their objectives are around intelligence gathering and being stealthy, which naturally means that they have to be, they go at great lengths to avoid getting caught. So stealth is a huge priority for them. The other interesting thing is their tradecraft is very novel, and they've dived into things that other adversaries have not in the past. They've done things like C2 via satellites, the Exchange server backdoor that we are going to talk about, and other things that were not heard of before when they were released to the public. So certainly a very audacious adversary, and you have to give credit for their boldness in trying new things. And so what it is that we emulated was their Exchange server backdoor. Now, the industry publicly knows this as LightNeuron, but if you're a CrowdStrike intelligence customer, you will know that this is, we refer to this as Blueprint. So you can go look up the CrowdStrike intelligence report as well, but the one that's public which is by ESET, and huge props to them because they've done very excellent work, and they've done their analysis is very thorough, and it's a great report. I highly recommend that you all read it. So yes, LightNeuron. It's a backdoor, but it's not just a backdoor. It's cool and interesting because it supports command and control entirely via emails. So no HTTPS, no FTP, ICMP, the usual suspects, none of that. If you have this backdoor installed on an Exchange server, you can send commands, receive output entirely via emails, which is what makes it very stealthy and hard to detect. It also has other features, like it can modify emails that are coming in. It can intercept them, block them entirely, hide them, and also it can receive commands in the form of attachments, which use steganography. So they look like real attachments. They look like a legitimate PDF or an image, but there would be malicious code within it using steganography. And one of the most complex parts of this backdoor is that it's not straightforward to remediate or remove. So you can't just go and delete the files once you found them. You have to first disable it, uninstall it, then remove the files, and then restart the Exchange server. If you deleted the files directly without doing that, you would break Exchange, which means you would no longer be able to send or receive emails, which is a huge problem, of course. So the way we approach this is actually very similar to how MITRE approaches this. I believe Adam has also given a talk on adversary emulation and spoken briefly about Venomous Bear in the past. And so we adopt a very similar approach wherein we gather the intelligence and then we extract all the techniques and then analyze and organize them into different groups. And naturally, the attack framework helps us in this. Then we develop the tooling, and then we emulate it. And of course, after that, we measure the gaps, which directly leads to us improving Falcon. And I know we have a lot of Falcon customers here, so you're welcome. So let's get right into the tradecraft of this toolkit. What does this entail? LightNeuron is not just one piece of software. It's a combination of 5 different components. So first, there's the PowerShell script. It's the installation script. Then there's the mail transport agent itself, which is the backdoor. Think of a mail transport agent as a plugin, as an extension of your browser. So if you've seen that, if on your email, if you've seen that button which helps you report spam or which helps you report the email to your blue team, that's how you have a mail transport agent. So that's the functionality of it. It extends Exchange servers. Then there's the companion DLL, which is written in C++. The companion DLL is what does all the heavy lifting. It parses the attachments. It runs the command. It has the Win API call to create process and so on. And then there's an encrypted config file, which is written on disk, and it's masquerading as a legitimate Exchange file. So it makes it a little bit more tricky to detect and identify as anomalous. And then lastly, there's the rules file. So the rules file decides what happens when an email comes in. If it's coming from a specific sender, then what do you do? If it's coming from someone you expect it to come from, and if you want to hide the email entirely, then that's the file where all of that gets decided. And we're going to get into each of these components. So as you can see, the PowerShell script that is used for installation, it uses default PowerShell commandlets that are installed on an Exchange server. So you'll see install transport agent, enable transport agent, get transport agent, and so on. And at the bottom, you'll see a procmon screenshot where you'll see the edge transport process opening the agents.config file, not to be confused with the config file of the toolkit, but the agents.config file is the file that gets modified when you install a transport agent. And we'll come back to this in the end when we talk about detection and response. But for now, just remember that agents.config is the file that has to be modified no matter what. And there are multiple ways to install this toolkit, this backdoor, but this is one of them. And then, of course, there's the mail transport agent itself. You have event handlers here. You have all the things like what to do when the email arrives, what function to pass it on to. So here you have the reference to the companion DLL, which does all the heavy lifting. Then the companion DLL, as I mentioned, the one that LightNeuron or Venomous Bear used had 3 export functions. It did a lot of the parsing of the attachments, and this was the main part of the backdoor. And then, of course, there's the config file, which you'll see some interesting parameters here, like the zip file name, for example, a little bit at the bottom. This is the file name that is used to finally exfiltrate all the output back to the attacker. And then there are some other the keys are encrypted in the config file. The config file itself is encrypted, and right on top you have the reference to the rules file that I mentioned, which is in XML. It has all the conditions that you want to have in the backdoor. So if you want to do malicious things, you would have conditions like, okay, if the subject contains this keyword, then do X or do Y. And you'll see, once again, the screenshot of Procmon, where edge transport, which is the Exchange server process, which is opening, reading the rules file, which is mocf.xml. Right, so now you have a rough understanding of what the toolkit does. What we move to now is the analyzing and the organizing of the MITRE techniques, and the attack framework naturally helps here, because now we can sort everything into, okay, initial access, defense evasion, execution, exfiltration, which is the most important part here, collection. And these are all the techniques that we gathered from both the public and the private reporting. And the other thing that we did was then compare it with what MITRE thinks LightNeuron does. So this is slightly different. There are a few more techniques here, and those are the ones that we gather and emulate in the end. But now you look at this and think that, all right, these are a lot of techniques to test into one toolkit. And if you want to automate it, if you want to do this again and again in a repeatable manner, then you'd have to come up with a better way than using isolated atomic red team tests. I've heard this on this stage so many times, that the idea of using attack is not just taking individual techniques and just testing them without context. When you have a toolkit like this, which is slightly more sophisticated than an atomic red team test, then context really matters. Which process is executing it? What do the parent-child relationships look like, and so on. So how do we deal with this? Micro Emulation Plans. Now, MITRE released this very recently, and I highly recommend going through their blog post. Micro Emulation Plans are like the perfect middle ground between an atomic red team test and a full-blown emulation, which is what you will see more likely in a red team assessment or a purple team assessment. But Micro Emulation Plans are perfect because now we can combine 2 or 3 techniques and test them together. And this really helped us, because what we did was we created a plan, we executed 2 or 3 techniques, then we improved on it. We added a few more techniques, then we added some more, and then some more. And then we had iterations of our malware, which eventually got better from one place to another. And And then we had the entire toolkit which we could test. So with that, I hand it over to Vishnu to go into the emulation.
Thanks, Raj.
Great.
So in order to emulate this very sophisticated adversary, so what we adopted was a micro emulation approach. So in this micro emulation approach, what we adopted was an assumed breach approach. Most of you know what is assumed breach. So we assume that an attacker already has foothold on the organization and has access to the Exchange server. So we did the initial stages in 4 different ways. First, we use the Exchange management shell, which is a feature already inbuilt in the Microsoft Exchange server. We use the commands that are used to install the transport agent, which is the install transport agent. Then we use a normal PowerShell agent, PowerShell instance, and we used an add ps snap-in import, which imports the commandlets that are used for Exchange servers to install the MTA or the mail transport agent. So the third one was using an Exchange server PowerShell instance through a Venomous instance. That's we are not touching anything on the disk, and we are using everything remotely. So we are calling the remote Exchange PowerShell instance through Venomous. So that was a little object. So the fourth thing was this was very straightforward, but when we literally went into and emulated this, we saw that it is better than everything from an object aspect. So it was just manually modifying the agents.config file, which is actually used by edge-transport.exe to load the transport DLLs. So this was way better from an OPSEC aspect. So this is just a snippet of how we wrote that. So this is showing the how we did the Venomous session, and down you can see the edge transport loading the agents.config. Okay, so then we started developing the malware. So we were like, so how do we approach it? So even though we are taking an assumed breach approach, we cannot directly go and emulate a very highly sophisticated, because we are gonna lose some low hanging fruits. So yes, then we thought like we'll do it in an increased sophistication level. So we'll build a basic thing, then we'll add complexities and sophistication to it, so that we don't miss the lower hanging fruit as well as the highly sophisticated parts. So the first generation of the mail transport agent, we can call it as MTA. It's very simple. It was basic functionalities of reading an XML rule file from the disk, which LightNeuron did, Sajal described on the trade curve section. And when an email comes in, reaches the Exchange server, it passes the subject of the Exchange of the email, and if there is a particular keyword which matches the rule file, then just prefix it or perpend something like say we are adding an external, so that it will deceive the end user thinking that this is from a different or outside the organization. So that's what that's a typical kind of situation what even Turla also did. So the first generation companion DLL, we used open source libraries to create the AES decryption encryption routines, and we hard coded encryption string and passed in the decrypt function. So these have been done very as a standalone thing with basic building blocks. It only performed decryption. So on the second generation, we added more complexities. We added a little bit of sophistication. The mail transport exactly passes the attachment on the email. Once the email comes in, the passes the attachment and retrieves the string, which is encrypted in AES. Once the AES text is retrieved, it passes to the companion DLL, which is passed to the decrypt routine of the companion DLL. So on the companion DLL, the second generation of the companion DLL, we added more complexities. So once it gets the passed attachment, which is the AES encrypted one, it decrypts that and checks for a prefix. So prefix is nothing like Turla use something kind of 0x01, 0x02. This 0x01 denotes something similar to code execution. 0x02 denotes something related to data exfiltration. So once the companion DLL finds the string has a prefix of 0x01, it knows that the rest of the payload is as a command to the command execution. So we did the command execution in different ways. We used a CPP system call, and then we also used a create process to execute the process. So the third generation of DLL, which had the most sophistication, same as Turla did. So we tried to mimic all features of what Venomous Bear did on LightNeuron. So when an email arrives on the Exchange server, the MTA passes it, gives the encrypted string to the companion DLL. So the companion DLL decrypts the string, and if the prefix matches the exfiltration code, then do a zip of the sensitive files. The sensitive files are like kept in a public repository. We assume that. So zip it on the memory. This all happens in memory. So zip it in memory, encode it into base 64, and then add it into an EML file. So the EML file on the right hand, you'll see the screenshot, and the EML structure is already predefined to what address it should go and to from address and the subject and everything, and it just adds the base 64 encoded sensitive file zip file. So once that is done, that is placed into a folder which is known as like pickup folder. So the pickup and the replay are the two folders of Microsoft Exchange, which is a feature of Microsoft Exchange actually. So every 5 seconds, it looks whether the folder has an EML file. So if there is an EML file, then it passes the EML file to find the recipient, the from address, and it takes in the data and sends an email. So that's why it's Turla used the same Microsoft functionality to exfiltrate data. So this is emulation in action. So this is what after installation of the transport agent. So you can see the Turla MTA agent already installed. This is just a normal mail which comes which is received at the recipient end, but you should always think like the execution already happened at this time on the Exchange server. Yeah, this is one interesting one where you can see the edge transporter exe is calling cmd.exe. On the right hand side, you can see that there is a cmd.exe executing beacon.
Right. So now that you know how we emulated it, we also needed to come up with a way to detect our own tradecraft or Venomous Bear's tradecraft. So if you remember, I mentioned the agents.config file, which has to be modified one way or another, no matter how you install an MTA. And so we looked for modifications to agents.config, which did not come from Exchange or which did not come from an Exchange-backed service. We then also looked at parent-child relationships. So if we saw edge transport spawning CMD or PowerShell, that was immediately recognized as anomalous. And then we had sandbox automations to send interesting files placed in interesting locations. So like the config file that I mentioned, the file was placed in the temp folder. And as soon as the file with a name that we thought was interesting, like a .dat, placed in the temp folder, we sent it to the sandbox for further analysis, and then we had our own sandbox rules. One of the more high fidelity strategies was to look at unsigned DLLs being loaded by Exchange, so specifically edge-transport.exe. This gave us a lot of good results because the MTA and the companion DLL that we loaded were not signed. And then in the end, we supplemented all of this information into the XDR, where we wanted to go from the email arriving, something malicious happening, and then to tie it all together, we could then see it in one view. Some of the challenges we faced were that the adversary itself is highly sophisticated. The malware was not straightforward. The toolkit had far too many dependencies, and it did far too many things. It was not just tailored to exfil or command execution. The public Intel reporting for Venomous Bear, if you've noticed, is very malware specific. We don't have actual intrusion data. We just have reports based on someone somewhere uploading a sample to VirusTotal and the industry then writing reports about it. So that was a big challenge we faced. And then in the end, of course, it was not easy to automate because of all these dependencies, the environment itself. But it would be unfair if I did not mention the biggest challenge we faced. And that was Exchange. Huge shout out, massive respect to all the Exchange admins out there. If you know an Exchange admin, hug them. It's incredibly difficult to debug the Exchange server, let alone run it, maintain it, keep it updated. So this for us was the single most biggest challenge. It was not easy to automate. It was not easy to debug. Emails would not come in, or emails would not go out. Yeah. And with that, I would like to open the floor for questions.
Thank you so much. I think we probably have time for one or two. I have one of them in my back pocket, but if we have any takers, come on here. So just to repeat for the online audience, what's the general availability of these emulation? Is this just a proof of concept, or is this something that you're planning to open source, or?
No, for us, this is just an internal proof of concept. So we built this in preparation for the MITRE attack enterprise evaluation, which was held a few months ago. And so MITRE also has released their own version of LightNeuron, which they used in the evaluation itself. I would highly recommend that one. It's very good work. I was just speaking to Jamie before the talk and praising MITRE for their version of the same implementation, and it's open source now. So, yeah.
I think there was another question over here.
Yeah, so quick question. So there's a lot of guidance around moving away from an on-prem Exchange server to like O365. Based on your research, is that also part of the guidance that hey, this is better in O365, or does it matter? Or does it not matter? And regardless, you have to kind of do these detections and so on.
So just to repeat for the online audience, basically, did this simulation highlight a leaning towards more moving from on-prem to O365, or did the simulation kind of more show that a balance in either way in terms of a good mitigation plan?
So let me take a step back and mention that when the report came out, O365 was not as big, and this report mentioned on-prem Exchange, because at that time the targets were mostly government institutes, diplomatic missions, think tanks, and so on, and they are on-prem Exchange. Now I know right now today in 2023 we have a lot less on-prem Exchange servers. Most of the organizations have moved to the cloud. It's not for me to recommend what you should do. It depends on your organization. If you work in the government, I'm guessing there's an affinity to stay on-prem rather than to go on the cloud. But if you're a private organization, you would naturally be more open to that.
Well, I definitely know you two are going to have a good time with Cat on the couch. Looking forward to that. But small token of our appreciation. Excellent job. Thank you so much.
Thank you.